This video is mixed problems of stoichiometry, going from volume to grams, or grams to volume, or grams to our particles, so our twin mole cities. So this is worksheet 3 of your homework, and I'm going to do 2 problems. I'm going to do number 2 and number 3. Number 2 first. So we've got our balanced reaction, and the question is, if 5 grams of KClO3 is decomposed, what volume of O2 is produced at STP? So the first thing we're going to do in our problem is figure out who our known and our unknown are. So I'm given this 5 grams of KClO3. So I'm going to find KClO3 in my balanced reaction and identify him as my known. I am solving for O2. I want to know the volume, so he's going to be my unknown in my problem. So now I'm going to start to set this up. So I'm going to get my grid ready. And like always, I'm going to start with my known. So I know that I've got 5 grams of KClO3. In order to move out, I need to convert to moles. So I'm going to use my molar mass to do that. So what's the molar mass of KClO3? So I'm going to need my periodic table here. So I'm going to need my periodic table, if I can grab it. Oop. And I'm going to find K on here. So I need to get out of here problem. So K. So K is 39. Cl. Right over here. Cl is going to be 35. And O, and I've got 3 of them in this compound, and oxygen is 16. So I'm going to add these guys all up, and I'm going to end up with 123 grams for my molar mass of KClO3. So I want grams out of here. 123 grams of KClO3 is going to go on the bottom, and that's 1 mole of our KClO3. Now that I'm in moles, I can do my mole to mole ratio from my balanced reaction. So I've got my known already identified, 2 KClO3s to every 3 oxygens. But I don't want moles of oxygen, I want volume. So now I'm going to go 1 mole to my conversion. My conversion for volume is 22.4 liters. So multiply across on the top, we get, so 5 times 3 times 224, we get 336. 123 times 2 on the bottom, we get 246. So then 336 divided by 246, and I get 1.37 liters of O2 for this problem. So again, if I look at my grid, I'm going to start with my known, and this time it was in grams. So I'm going to do a molar mass conversion in grams to get my 1 mole. Then I'm going to do my coefficient of my known, coefficient of my unknown, then 1 mole on the bottom to whatever conversion I need here. This time I was going to liters, so it was 224 liters. So that's how you set up your grid. Let's look at one more problem. So here we've got the same reaction, but this time we want to know our grams. So how many grams of potassium chloride would be produced if 2.5 liters of oxygen was consumed? So my unknown is my KCl, so find him in your reaction and identify him. Oxygen is my known, 2.5 liters. So start with your known, 2.5 liters of O2, but I don't want liters, so 2.24 liters over 1 mole, and this is still O2. So I don't want O2, I want KCl. So we're going to go to our reaction and use our ratio. 3 oxygen to every 2 KCl's. But I don't want moles of KCl, that's what it's going to leave me with here. So now I need to do my conversion into grams. So we're going to do our molar mass. So let's get our periodic table. So K on the periodic table is 39. Cl, I can't see him, so let me move my periodic table. Cl is 35. So I add those guys together. So 39 plus 35, my molar mass for this compound is 74 grams of KCl. Multiply across, multiply on the bottom, and then divide. So 2.5 times 2 times 74, I get 370. Divided by 22.4 times 3, that gives me 67.2. When I divide those, I get 5.5, and I'm ending up with grams of KCl. So double check, liters cancel of my O2, my moles of O2 cancel, my moles of KCl cancel, and I'm left with my grams. So that is mixed problems of stoichiometry.